Hi, in this video we're going to look at trigonometry, specifically trig equations, and in trig equations the general solution of a trig equation. And this is grade 11 work. So let's go. Why general solution? I think we need to understand where this is coming from before we even get to the calculations. You would have had your normal trig equations. Take for instance an equation of sine theta is equal to 0,5, and initially you would have been really expected to solve in grade 10 for your angles that are in the first quadrant, that is between 0 and 90, and then in grade 11 you would have then introduced to finding solutions in the first four quadrants, that's from 0 to 360. And with every single trig equation you would have been expected to get two answers there, depending on whether you're dealing with a ratio that is negative or positive. And in this case of this example, we're dealing with a positive ratio, meaning the quadrants where sin is positive, and that would be the first quadrant and the second quadrant. And yes, it was fine. In the first quadrant our answer was 30 degrees, and in the second quadrant our answer was 150 degrees. Now, it so happens that these are not the only angles that actually give us a solution for that equation. And then in grade 11 you get introduced to a way and something that helps us to write all possible angles that can go into that equation, and that's what is called the general solution. There are infinitely many. There are positive angles that go up to negative infinity. There are also negative angles that go up to positive infinity. So you've got angles, a range of angles going from both negative infinity to positive infinity. Now it's impossible to write all those possible solutions, because we can do that in a case where we've got an equation that is asking us for the two quadrants from 0 to 360. That's pretty easy and straightforward. But how then do we write those solutions where we find that our solutions go beyond 360? They go up to positive infinity, and they go below 0 up to negative infinity. And that's what we're learning right now. Now, just a quick illustration. Those solutions, the 30-degree solution would have been there in the first quadrant, and then the second solution would have been there, the 150-degree solution. What if we continue adding revolutions on that? Every time we hit each angle, we get a new solution with each revolution, and the revolutions will go on and on around your Cartesian plane there, and giving us new solutions every time, and that goes up to infinity. So how then do we write those possible solutions? And mind you, this is only for positive angles. We're still going anti-clockwise. We still have to think about those angles that are going clockwise, which are negative angles. Okay? Now, clearly, each revolution introduces a 360. So then when we write that solution, we'll say, oh, well, that first quadrant solution of 30 degrees, and we're going to keep adding those revolutions however many times we need to add them. And we can't even have a value that says, oh, there will only be 2 revolutions, or there will only be 3 revolutions. The same thing happens with the answer in the second quadrant. We're going to keep adding revolutions that give us the new solutions. Okay, and yes, depending on the number of revolutions, we'll then be able to put the value of k. Hence, the value of k, by the way, is integers. Okay, which is very important when you write a solution. Now, if then we're still just giving the first 2 solutions, that means our value for k is 0. There is no revolution that we've completed. As soon as we start completing a revolution, then new values come up. For instance, in the first quadrant, we'll now hit 390. In the second quadrant, 510. That's just one revolution being added on. If 2 revolutions were added on, meaning the value of k now is 2, then there will be 750 in the first quadrant. There will be 870 in the second quadrant. And this goes on and on. Up to infinity, giving us new solutions to that equation. So the first 2 solutions of 30 and 150 are not the only solutions. So we then need to have a way of writing all those possible solutions. And here, this is where our general solution comes in. How do we write solutions that will represent all possible solutions in an equation? Okay. What about negative angles? Because all that I've shown you now is just positive angles. Well, when we change our values of k, remember our k is an element of integers. When we change our values of k to negative integers like -1, -2, -3, and so on, we now get the outcome of those negative angles. I'll just take a few. For instance, for that first solution up there, the first value of k, which would have been -1, would give us -330. In the other solution, the first value of k of -1 will give us -210. And those angles are actually correct values that would have solved the equation. If value of k is -2, here are our values, -690, -570, and this goes on and on and on as you're increasing your values of k and adding on your negative numbers. The bottom line is, for both negative and positive angles, there are solutions to that equation, but it's impossible to write all of them. You'll never finish. They go up to infinity, they go up to -infinity. So we need a way of writing our solutions so that we represent all possible solutions, both negative and positive, for any trig equation. That's what a general solution is all about. So let's go and have a look. But first, we need to summarize just quickly what is it that you have to do to write your general solutions. Take, for instance, if we had a sine equation, like the example we had, well, we are assuming here that everything is positive, so we're dealing with positive ratios, and that's why our first solution would be in the first quadrant for that, and another solution would be in the second quadrant, which is a 180 minus quadrant. Remember your reduction formulae. But what are we subtracting? What are we doing here? Well, we're just basically subtracting the reference angle that we'd have found from your calculations earlier before you write your general solution. So it's very important to understand that this sign to the -1a basically represents our reference angle that we'd have obtained. Same thing happens with the cos, positive in the first quadrant and also positive in the fourth quadrant of 360 minus. And that will be perfectly fine, and that will be our fourth quadrant. Same thing with 10. 10 luckily is a very nice one. As soon as you get your reference angle or your first solution, you take that solution and you just write only one solution, repeating itself every 180. You will see this in a sine graph, in a 10 graph, unlike a sine and a cos graph. Things repeat themselves every 180, whether it's asymptotes, whether it's the solutions, everything repeat itself every 180. Okay, it's much more easier, and that's why for 10 you just need to write one solution and you're done. Just find out that first solution that goes there and then you're perfectly fine. Okay, let's now go to some examples. We're asked to determine the general solution. Here again, remember, it's very important to remember your CAS diagram. Here's an example. Sine theta is equal to 0,794. Well, reference angle first. Our reference angle is 52,56. That's easy. That means first quadrant, remember, we have a positive ratio. So first quadrant would be that value repeating itself every 360. Don't forget in that first line to always write k as an element of integers. And this comes from the second quadrant, 180 minus our reference angle. You don't even need to show us the calculation. You can just show us the outcome, use the calculator, and that's perfectly fine. Also repeating itself every 360. And that would have been done. That's our solution. So basically what you are adding to what would have been normal in the first two quadrants, you are adding that k times 360 in each case, meaning that solution would repeat itself every 360. Here's another one. Obviously, equations don't come ready for a calculator. Manipulate your equation and divide by 3. Now you get to a stage where you're ready for a calculator. Remember again, if you're going to use this approach, don't punch your negative. Just punch the actual ratio that you see there. And therefore, that gives us a reference angle of 35,97 degrees. Now you're ready to go to the quadrants where cos is negative. And that would be the second and third quadrants, 180 minus and 180 plus. Let's go. Write your general solution, but be careful. This 2 theta will now take it and use it in the quadrants. That's why you see there that when we go to the second quadrant, we've got 2 theta there. Subtract 180 minus your reference angle plus k times 360. Manipulate, that means divide everything by 2. So you have to divide both that angle there and the 360, and that's why we've got k times 180. And that's our answer. And again, if we go to the third quadrant, that's 180 plus that reference angle, and that's why we've got this value, and then we divide everything by 2. There's our solution. So pretty easy there. Let's take another example, and here we've got a 10 example. Again, divide by 5. Now we're ready for the reference angle. Calculator, shift 10 and the value on the other side. Again, do not punch that negative. Okay, we just want to get our reference angle, and then when you get your reference angle, you are able now to go and say, right, I know where my first angle would be, where 10 is negative, and that could be in the second quadrant. So 180 minus that gives us an angle that we can use to write all possible solutions. And in this case, take note, our angle was 2x minus 44, so we bring it as is to our solution in order to write the final solution. And when we do that, we add the 44, we then divide everything by 2, and finally our answer comes out. And this answer is the answer that will cover all possible answers. Remember, for 10, we only just write one solution, and we're done. Okay? Here's another one, quick. Again, reference angle. We're looking for quadrants where cos is positive. We've got our reference angle, and then we go again and write our general solution. And that only just covers only the first quadrant. Okay? Take note, in the first quadrant, you use your reference angle as is. The other solution is in the fourth quadrant, and hence we get that 303,74 there from 360 minus our reference angle. Then you solve and you get your general solution. So those two solutions are the solutions that would cover all possible angles, both positive and negative. That will be solutions to that equation. Okay, pretty easy. Just remember what you're adding that is important for your general solution.